Okay, so for today, you're going to do a little extra practice with your concave mirrors. So you're just going to go through, do salt for each one of these. So you're going to describe the characteristics and yeah, and then just so you know, these diagrams only have the focal point on them. So no center of curvature. So you're not going to be able to use that third method where you go through the center of curvature and straight back again. But as I said yesterday, that's not really a great method. So again, you're going to use parallel focus, focus parallel, find that point of intersection. If one of those doesn't work, you can't do one, then you're going to draw your rays to the vertex here and do angle of incidence equals angle of reflection and reflect the ray back at the same angle. So hopefully you still have your protractors and you can find your point of intersection of the reflected rays that way. So just a little bit of extra practice. And then I'm just going to quickly go through one example down here. So I want you to do those. I think I want you to upload this. So I just want to see how you're doing. So not for marks yet, just so I can check your work, make sure you're on the right track before we move on with convex mirrors. So yeah, definitely upload this when you're done this worksheet for today. So next is calculating magnification. So magnification is how much larger or smaller an object is compared to the actual object. And it's calculated using this formula. Magnification equals the image height over the object height, or the image distance over the object distance. Okay, so it really depends on the information given. Sometimes they'll use distance, sometimes they will use height. So it just depends on the question, okay? So here's your formula. And again, you have to be able to rearrange this. So sometimes you have to be able to find the object height. So real quickly, I'll go over that. So you just have to re-isolate. So let's start with the simple one. So magnification equals, let's isolate image height. So we want to solve for HI over HO. So to do that, we need to isolate the HI. So we need the height of the object moved to the other side of the equal sign. Since it's being divided on the right side, to move it to the left, we're going to multiply. So we're going to get magnification times the height of the object is going to equal the height of the image. Okay, so that's just rearranging that formula for the height of the image. So that's an easy rearrangement. And then I will rearrange for the height of the objects. That's a little more difficult. So again, we start with magnification equals the height of the image, and now we're going to be isolating the height of the object. So first we need to get rid of it on the denominator, so we're going to multiply it up to the other side. So height of the object times the magnification equals the height of the image. And now we need to isolate it, which means we need to move the magnification from the left side to the right. So we're going to divide both sides because it's being multiplied. It's going to cancel here, which leaves us with the formula height of the object equals height of the image divided by magnification. So there you have three formulas depending on what you are trying to find. Okay, I'm just going to erase that. Okay, so I'll go through the first example with you, and obviously the examples are going to get a little more difficult as you go through. So again, questions, just ask. I'll send you a little video if you need some help. So our first question, and again, physics, math, write down your givens. It's been proven that by writing down your givens and your formula, you're more likely to get the correct answer than if you don't. So let's just do that. So what we have is three variables here. So magnification, height of the image, height of the object. So we have a microscope produces an image that is 5.50 times 10 to the negative 4 meters high. So that is the image height. So that's the image height. So 5.50 times 10 to the negative 4 meters. I love it when I do this. I don't know how I do. Okay, that is my hand leaning on my tablet, I think, is causing that little problem. Okay, so from an object that is, there's the height of the object, 2.00 times 10 to the negative 6 meters. So obviously we're trying to find the magnification, which states right here. Calculate the magnification. So the first thing you want to check is that your units are the same. Remember, we went through converting units the other day. There's a reason we did that. Okay, so you're going to encounter differences in units. So when you write down your givens, it's a lot more obvious if you have issues. In this case, we do not have an issue with units, so we can just go ahead and sub it into the formula. So write down your formula, HI, HO, sub in your numbers. Okay, and then you're going to, use your calculator. Find mine. Here we go. And again, you just plug those numbers in. Hopefully you've become accustomed to the scientific notation. Equals. So I get 275 times. That's the magnification. So the magnification, therefore, the magnification is 275 times. Okay, and that's how you do those questions, including the statement at the bottom, all the givens, write down the formula, sub in your numbers, make sure your units are right. Okay, and that's going to be it for today. So I want you to try and work through this worksheet, and again, just upload it so I can see how you're doing. I just want to see how things are going with physics, because physics can get overwhelming quickly if if you let problems slide. So hopefully that will work well for you. And we'll go on to convex mirrors tomorrow.